Alright, so to start this electricity and magnetism tutorial, we really need to focus on the strategy you're going to use to solve problems. And this indeed will be the focus of the video, to make sure you can follow strategy. You'll end up having to remember less, and if you blank out, you'll have something to fall back onto. So starting with number one, when you see a question, you need to give yourself a goal, and that would be by finding the question. So let's take a look at question number one, and let's give ourselves a goal. It says here to state what 12 volts and 5 watts means, and it's making it clear that we're referring to this item right here. So we can go ahead and take a look at our strategy, and we got to track data now. So the data that we're presented with in this question here is very simple. It's 12 volts and 5 watts. So there's really not much data to track here. I'm going to go ahead and answer the question. We don't need a formula, so I can say when voltage measured across the lamp is 12 volts, we can expect a 5 watt power output, and that would be as light and heat. Okay, and that's the first question done to an achieved level. All right, let's move on, and we're gonna move on by focusing on our strategy. So first of all, we need to give ourselves a goal. So let's take a look at question 2, and let's do that. So we have some information, and the question here is asking us to state which of the two lamps will be brighter. Okay, and that's our question. I've got the question identified. I know what my goal is. So right away, I'm going to take a look at my strategy. I've given myself a goal. We're going to start tracking data. So let's go ahead and do that. And we can take a look at the fact that we're comparing two lamps. So I'm going to call this lamp A, and we'll call this lamp B. So I'll make a note over here that lamp A has voltage equal to 12 volts and power equal to 5 watts. All right, and similarly we got lamp B at voltage of 12 volts and a power of 18 watts. All right. Well, when we're talking about the brightness of a lamp, we're talking about the power of the lamp itself. So there's a little bit of knowledge that goes behind this question, because you want to give some reasons for your answer. So right away we're looking at a merit question because of the reasoning. So let's start off by answering the question. I'm going to say that lamp B will be brighter. I'm going to answer the question. Here's my reasoning. First of all, both lamps will get 12 volts because they are in sorry about that. So lamp B will be brighter, and the reasoning is both lamps get 12 volts. So that means the power output depends on the power rating, since both lamps have the same voltage, and we can include that we know 18 watts output power is greater than 5 watts output power. So the 18 watt bulb will be brighter. All right, and that's done at a merit level. Great. Let's move on to answer this next question here, which goes to an excellence level. So we'll really take our time going through this one, and let's refer back to our strategy. So we're going to start off by giving ourselves a goal. That's going to happen by identifying the question. So let's get into this. Calculate the effective resistance. So we want to know resistance, and I can make a little note to myself here. Resistance equals what? All right, and I've got data tracked here from the previous question, and I'm very much going to use this data. All right, taking a look at our formula sheet, we've got a couple of ways that we can calculate total resistance. For a circuit in series, there's total resistance. For a circuit in parallel, this is total resistance. Now this is the one you might think you want to use. However, when we take a look, we don't have these R1 and R2 values. That's not given in the question. Take a look. We don't know the resistance of these values. So we're going to have to use this equation right here in a global sense, using total voltage and the total current to find resistance. So let's go ahead and do that. I'll show you what that looks like right now. Well, what does total resistance equal to? Well, I know V equals IR, so R equals V over I. All right, that's using algebra to rearrange V equals IR to get R equals VI. Now, I know this value right here. The total voltage is 12. I'm trying to find the total resistance. I don't know the current, so can we calculate the current? I believe that we can. All right. So this is where tracking data is crucial. I've got power here, and it would possibly help for me to write down power equals IV, and that comes from your formula sheet right here. Power equals IV. And that's really the key to solving this problem, because we can go ahead and rearrange this for current equals power over voltage. Right? And if you take a look, we've got power and voltage for both lamps, so we can solve the current for both lamps. So I'm going to say the current at lamp A equals 5 watts divided by 12 volts. 5 watts divided by 12 volts, which equals 0.42 amps. And the current at lamp B equals 12 watts divided by 12 volts, which equals 1.5 amps. Now, since I know how current flows in a circuit, I know that 0.42 amps right there is going to come around out of this branch and meet up here, and also and then 1.5 amps is going to come out of this branch and meet up here. So you got 0.42 coming and meeting up with 0.15 amps. So I can go ahead and make a statement here that the current total, equals 0.42 plus 1.5, which equals 1.92 amps. And what I just found was this value right here. So the question's very quickly breaking down, and we're going to add to this here. So now I know resistance is going to equal to the 12 volts divided by the 1.92 amps. Give me total resistance is 6.25 ohms. Right? And this question has been done now to an excellence level. And I'm very quickly going to recap what was done to solve this problem. So calculating effective resistance, we didn't have the resistance values for these lamps, so I went and used V equals IR in a global sense, taking a look at the whole circuitry all in one shot using V equals IR, rearranging for resistance equals voltage over current. I realized, hey, it's just that total current that I don't know, and that's what I solved for by determining the individual currents of lamp A and B, and that was using the formula, this formula here, which came from power equals IV. Alright, so really the key is to have the courage to use P equals IV, utilize those power and voltage values, solve for each individual current, use the knowledge that the current adds up together, and thus you have your total global current there. And last step would be to employ this equation to answer the question, and that's worth excellence. Calculate the energy transferred by the 18-watt lamp after 3 minutes. Okay, so there's my question. I've given myself a goal, and I'm going to start tracking some data. So I've got power equals 18 watts. I've got time equals 3 minutes, which is also equal to 3 minutes times 60 seconds per minute. Definitely want to convert that into a time value in seconds. Alright, so that's been done, and I've got power and time. I'm going to take a look at the formula sheet here, and what ties together the question, power, the question being energy, there it is, power and time, it's all right there. So let's just rearrange this formula for energy, and we'll be able to solve the problem. Alright, so let's go ahead and do that. We've got power equals change in energy divided by time. I can rearrange that to say energy equals power times time, substituting in my values, 18 times 180 seconds, and we definitely get a energy value of 3,240, and that'll be in joules. And we're done question number 1. Again, I'd like to remind you the most important thing really is to follow a problem-solving strategy. Give yourself a goal, track your data, choose a formula, answer the question. That's how I do each question every time. Hey, thanks for watching. If you have some time, why don't you click on this link in the description box of the video. That'll take you to Paid Surveys at Home, which is an awesome database of websites that pay you to fill out surveys. I've checked this out myself. The database is totally legit. This site itself provides the database and also the know-how for maximizing your profits and maximizing your time to profit the most with the system of staying at home, working whenever you like, and basically filling out surveys to make some extra cash. So if you want to make some extra money at home, check out this link at the bottom of the video in the description box.